Our topic today is the life cycle of stars. From stellar birth to cosmic grave. Introduction. Hello and welcome to the cosmic journey. Hey science enthusiast! Welcome back to Chisholm's Science Tech channel, where science becomes a window into the wonders of the cosmos. If you've ever looked up at the night sky and wondered where stars come from, how long they live, or what becomes of them when they die, you're in for a real treat. In this video, we're going to explore the entire life cycle of stars, from their birth in cold nebulae to their transformation into majestic giants, and ultimately, their deaths as white dwarfs, neutron stars, or even black holes. So grab your telescope and fasten your seatbelt, because we're about to embark on a journey that spans billions of years and countless light years across the universe. 1. Stellar nurseries, the birthplace of stars. Stars don't just appear. Their origins lie in enormous clouds of gas and dust scattered across galaxies, known as nebulae. These vast and cold regions are the cradles where stars are born. Deep dive. Nebulae are mainly made of hydrogen, with traces of helium and dust particles. These clouds can span hundreds of light years. External triggers like supernova shockwaves or galactic collisions create disturbances, causing sections of the nebula to collapse under gravity. As regions collapse, they fragment into dense cores. These clumps heat up due to compression, forming what we call protostars, the embryos of stars. 2. Protostars, the embryonic phase. As the collapsing cores get hotter and denser, we enter the second stage, the birth of a protostar. At this point, the object isn't a true star yet, but it's close. What's happening? Protostars emit energy, but not from fusion, it's all from gravitational contraction. As the temperature increases, convection currents churn the star's interior. Surrounding gas and dust may form protoplanetary disks, where future planets take shape. Over tens to hundreds of thousands of years, the protostar grows in mass, and its core temperature rises. Once it reaches 10 million Kelvin, fusion of hydrogen begins, and the protostar graduates to a true star. 3. Main sequence, the longest stellar life stage. When nuclear fusion begins, the star stabilizes and enters the main sequence phase, a phase that can last billions of years. Fusion and balance. In the core, hydrogen atoms fuse into helium, releasing vast energy through Einstein's E=mc². The energy radiates outward, balancing the inward pull of gravity. This equilibrium makes the star stable. Mass matters. Low-mass stars burn slowly, live up to trillions of years. Sun-like stars live till the 10 billion years. Massive stars burn fuel rapidly and live only a few million years. Stars during this stage fall along the main sequence line on the Hertzsprung-Russell diagram, with color, brightness, and temperature based on their mass. 4. Red giants and supergiants, the aging process. No star can burn forever. As the core hydrogen runs out, fusion slows, and the balance is lost. Gravity takes over again, and the star begins to change dramatically. Red giant formation, sun-like stars. The core contracts and heats up. Outer layers expand and cool, turning the star into a red giant. The star now fuses helium into carbon. Red supergiants, massive stars. Fusion continues beyond helium, forming carbon, neon, oxygen, and silicon, until iron is formed. These stars become hundreds of times the sun's size and shine with brilliant red luminosity. 5. Planetary nebula, a beautiful death for small stars. As a red giant reaches the end of its helium-burning phase, it sheds its outer layers in a spectacular display, forming a planetary nebula. What happens? Radiation from the exposed hot core ionizes the ejected gas. The glowing shell expands outward at tens of kilometers per second. These nebulae last for only a few tens of thousands of years, a blink in cosmic time. These are among the most beautiful objects in the night sky, a last burst of glory before the core fades into darkness. 6. White dwarfs, the stellar ember. What remains after the nebula fades is a white dwarf, a superdense core no longer undergoing fusion. Details. Size, roughly Earth-sized, but with a sun's mass. Composition, mostly carbon and oxygen. Bright due to thermal energy, but it will slowly cool and dim over billions of years. Eventually, it becomes a black dwarf, an invisible, cold remnant. But since the universe is only 13.8 billion years old, none have formed yet. 7. Supernova, the death cry of massive stars. Massive stars don't fade away, they go out with a bang. A supernova is one of the most violent events in the universe. Core collapse. Once the core produces iron, fusion ceases. Gravity overwhelms the core in milliseconds. Outer layers crash inward, then explode outward. The result can release more energy in seconds than our sun does in its entire lifetime. Enriches space with heavy elements necessary for planets and life. 8. Neutron stars, cosmic pressure cookers. If the remaining core is about 1.4 to 3 times the sun's mass, the result is a neutron star, one of the most extreme objects in the universe. Deep physics. In a neutron star, protons and electrons merge into neutrons. A sphere just 20 kilometers wide, but with immense gravity. Surface gravity, 200 billion times Earth's. Some spin rapidly, hundreds of times per second, and shoot beams of radiation from their poles. These are called pulsars. 9. Black holes, the ultimate gravitational collapse. If the core's mass exceeds 3 solar masses, nothing can stop the collapse. The star becomes a black hole. Black hole basics. Surrounded by an event horizon, beyond which not even light can escape. Space and time warp infinitely at the center, the singularity. Can grow by accreting material or merging with other black holes. Found at the center of most galaxies, including the Milky Way. 10. Stardust, the legacy of dead stars. Here's the cosmic twist. When stars die, they seed the universe with the elements of life. We are made from stardust. Cosmic recycling. Supernovae and stellar winds release carbon, oxygen, nitrogen, iron, the building blocks of life. These materials enrich new nebulae, giving rise to new stars and planetary systems. You and I are literally the ashes of ancient stars, atoms born in supernovae, now walking, thinking, and dreaming. 11. The fate of the Sun and the end of Earth. Our star, the Sun, has a future too. And so does Earth, though it may not be pleasant. Timeline. Till the 5 billion years, becomes a red giant. May engulf Mercury, Venus, and potentially Earth. Eventually sheds its outer layers, becoming a white dwarf. Humanity may need to find a new home long before then. 12. Conclusion. The eternal cycle of cosmic giants. From dust they rise, and to dust they return. The life cycle of stars is a breathtaking cosmic rhythm that writes the story of the universe. Final reflection. Stars are the factories of matter. Their lives shape galaxies, create planets, and give rise to life. Every time you look at the night sky, remember, you are part of this cycle. Thanks for watching Chisholm Science Tech. If this journey through the cosmos amazed you, make sure to like, subscribe, and share it with fellow space lovers. What stage of a star's life fascinated you the most? Tell us in the comments. Until next time, keep looking up, because the universe is alive with light, and your story began in the heart of a star.